The scientific revolution starts now.
The Demystified Broadcast.
Let us see in the dark.
My name is Alberto Martinez. I'm a professor at the University of Texas at Austin, working mainly on history of science. I'm also the chair of the Forum on History and Philosophy of Physics of the American Physical Society. I've written several books. Presently, I'm doing a historical novel about Albert Einstein. Part of the reason is because the biographies of Einstein just don't say so many things about him that were true that I might as well say them in a fictional format. And in that context, I thought it'd be interesting to talk a little bit about how scientists sometimes feel that they have to silence themselves, whether it's for professional reasons or whatnot. But it's kind of led me to think that there is this enormously powerful culture of silence that moves so many people, whether it's shy students sitting in the back of a classroom or famous scientists or historians, when they're asked to just tell us what we should do or what do you think about this, and they kind of check out on the topic, which is too bad because finally people get a chance to say something. They back away from free speech.
Silence does not immediately come to mind when you think of great scientists over the course of the last century or so. Certainly not when it comes to someone like Albert Einstein, who at this point is basically canonized as one of the greatest scientists of all time. And so I wonder if you can lay out some of the ways in which you see silence playing a role there.
Well, for example, during World War I, Einstein is now viewed as a relatively famous pacifist, partly because he signed and allegedly co-authored a pacifist manifesto titled Manifesto to the Europeans. The fact of the matter is, during World War I, he did nearly nothing on pacifism, and this manifesto that he signed was principally authored by a guy called Dr. George Nicolai, who kept pestering Einstein again and again to do things. And while Einstein would not, essentially, Einstein was just a guy working on his physics. He's not a guy standing on a sidewalk or giving lectures against the war or making a spectacle. In no way. I mean, this guy, much of the war, he's working at Fritz Haber's Chemistry Institute, which is a branch of the Ministry of War. Einstein has an office there, and Fritz Haber is developing toxic poison gases. There's not a single letter in which Einstein tells a friend, "Oh, I'm so annoyed that Haber is making poison gas to kill French and English people," or of an argument between the two of them. But at the same time, we know and we believe that he was a pacifist. In other words, Einstein's anti-militarist since childhood. He doesn't say want to join German military, so he renounces his German citizenship and so forth. But when you compare him to someone who's actually outspoken, like the pacifist Romain Rolland or the guy I'm talking about, George Nicolai, you see Einstein's not quite one of them. So at one point, one of his biographers, a guy called Ronald Clark, he said that for Einstein, pacifism was something for peaceful days. In other words, after the war, you take out your cloak of pacifism, you put it on, and you start talking about how bad war is, but not when you're endangering yourself. So in regards to the topic of silence, Nicolai, who was the cardiologist to the Empress of Germany, Augusta Victoria, and who was a professor of medicine at the University of Berlin, and he was a medical contractor for the military and an important medical doctor in developing electrocardiograms and in treating people at the Charité Hospital. This guy, who at some level is a member of the elite, this guy, George Nicolai, did dozens of initiatives from forming a so-called New Fatherland group to kind of create some sort of European culture instead of this nationalism that was so fervent and dangerous in Germany. And he, everything happened to him. He lost his access to the Empress. He lost his teaching job. He lost his job at the hospital. He lost his laboratory. He was disinherited. He lost his military contractor. He was conscripted by the army. He was incarcerated. He was demoted and demoted until the guy is basically a captive in a military camp, and they're training him to kill people. And what he does is, or they're trying to, and this guy actually escapes and lands in Einstein's apartment, and afterwards steals an airplane from the German Air Force. So Einstein witnessed firsthand, what happens to someone who actually speaks their mind. In other words, George Nicolai was destroyed from being practically the most pacifist, so most famous pacifist in Germany. In other words, imagine the courage it takes to stand up against this military regime in World War I and actually start saying things publicly, to becoming persona non grata. I mean, the guy was just clobbered by the media, by the professors, doctors, his father-in-law. So it's very dramatic. Einstein had this front row seat to seeing what happened to his activist friends. And another one was Fritz Adler, good friend of Einstein in college, perhaps Einstein's best friend when Einstein is a professor at the University of Zurich, because the guy got Einstein the job. Fritz Adler goes back to Austria, realizes that democracy is crumbling there because parliament has been eliminated. And then he takes a gun, goes to a prominent, famous restaurant, and shoots the president minister of Austria. In the middle of, at the height of World War I, one of Einstein's best friends, the physicist Fritz Adler, assassinates. He personally assassinates one of the heads of the Hydra. So Einstein, again, has front row seats to that. And he sees how Fritz Adler has been gradually crushed and will continue to be crushed by the Austro-Hungarian Empire because of these things. So Einstein discovers, it's like a scientific discovery, that the route to success professionally is to keep your trap shut.
This is wild, because you said at the beginning that there's no evidence of any of this in his letters. So he has front row seats, but he's not reaching out to people to tell them about what's happening at all?
No, Einstein does talk to people about the incidents I've described. What I'm saying instead is that there is a hopeful way of writing about Einstein in World War I, in which people imagine that he had a falling out with Fritz Haber. But there are no such letters in which Einstein said, "Hey, Fritz, I'm really annoyed at you because you're making chemical weapons." It just doesn't have. Fritz Haber is one of the members of the steering board of the so-called Institute of Physics that Einstein eventually heads. Fritz Haber is one of Einstein's main patrons and one of his best friends in Berlin. In other words, when Einstein is splitting up from his first wife, Mileva marriage, the guy who is negotiating that breakup is Fritz Haber, and not just initially to get her out of the city, but subsequently and for years. So Fritz Haber is a close confidant of Einstein. And why do people say, well, Einstein didn't feel this way or that way so well about Fritz Haber? It's basically, there are some spans when there are no letters. So, but no letters doesn't mean that people are not communicating. It means that they see each other often, so they don't need to write letters. Einstein's working at Fritz Haber's Institute, and so on and so forth. They don't need to be sending each other letters. But anyway,
they don't need to be sending each other letters, but you would expect, because I've read some of Einstein's communications, his letters to Solovine, I've read. Yeah. And then I started reading, there's a collection of letters between, I think it's Bohm and Planck and Einstein, and I think Schrodinger's in there as well, and they're all writing back and forth and, negotiating these questions of relativity and quantum mechanics, and so this is much later. But in those letters, something that I noticed is that there's almost no conversation about life, about things that are happening to them. When he's writing to Solovine, there's a little bit of details about, the girls are sick, we've recently moved, I was in America, it was interesting or it was difficult, my health isn't that good, everybody's doing okay, but there's not
worldly?
It's not worldly, and that's even after World War II, right? When he's writing in the 50s. Like, he doesn't seem to want to engage with it whatsoever.
And Solovine isn't doing it much either. At one point, Einstein writes to Solovine, and Einstein says, why do you write me this way? We're fellow mensch. We were pig herders. In other words, Einstein's trying to go back to, they were just relatively poor guys living in Bern. Living in Bern, Switzerland, when Solovin was studying courses at the university, and Einstein was an underemployed clerk at the patent office, and they became friends. And the times were funny and light, and decades later, Solovin is writing Einstein letters, "Dear Professor Einstein," and Einstein's like, "Dude, we were goat herders or pig herders. Like, we've been in the dirt together. Why do you write me with this tone?" And I'll tell you, I don't know from Solovin's point. I mean, it's obviously respect. Einstein shot up and became a world celebrity, so Solovin is writing with deference. But from Einstein's perspective, he didn't want many records of what he called the merely personal aspects of his life. So when people ask him, "Can you please do an autobiography," which he calls his obituary, he says, "What should matter about a guy like me is what he thinks about science, not the merely personal." But because there have been decades of work, historical work, in researching the merely personal, I personally eventually felt, there's a bunch of stuff here that doesn't show up in Einstein's biographies, and it has to be told. And some of it, again, just going back to the issue of World War I, during World War I, at one point, Einstein starts designing airplane wings for a military contractor in Berlin, Johannistown. And why is a pacifist designing airplane wings in the middle of World War I? I mean, these for a company that, for example, was making planes that were bombing England. So this is not an element that normally shows up in biographies of Einstein. And when one of those test pilots, because these planes were built and tested in wind tunnels, air tunnels, when one of these pilots contacted Einstein decades later, Einstein said, "I think about those days, I'm really embarrassed." And so here's a guy who does try to step away from some of his things, whether it's personal things having to do with relationships or some, I don't know. I mean, he worked also on gyro compasses for a guy who manufactured these things for the German military. You're at sea in a battleship, and the waters are too violent, so a magnetic compass won't work well, because you shake a magnetic compass, it's not something that works anymore in terms of for orientation. So Einstein worked on patents for gyro compasses that resist shock, which is precisely what you need on a ship in the war. And these things were eventually used in U-boats and German vessels into World War II. So again, Einstein's a weird, eccentric guy who's fascinating partly because of that, but then people try to make him into this weird, saintly Old Testament prophet, and then we get this. I don't know. It's like a disjunction.
I mean, I think the most disturbing part about this is that it seems like if Einstein is, widely heralded to be like the smartest dude ever, and he comes down on the conclusion that me speaking out isn't going to accomplish anything, and in fact, it's going to derail my ability to change anything productive in the world, that this really brilliant guy has essentially reasoned that there's no point in breaking silence on some issues.
Yeah.
Because you can imagine a different world where he had, and would that have threatened his ability to bring forth his physical ideas into the world? Would it have alienated him from the societies that he needed in order to develop all those ideas? Would he have found himself also driven out of all of these scientific societies and unable to, would he have essentially been excommunicated? I guess is the question. Did he really have a choice? Was it sort of destined to be this way if he wanted to communicate scientifically?
That's a great question, especially because you used the word excommunicated. I think what's at stake is that. I think there's a line that someone crosses and becomes persona non grata to the civilized world, and someone like George Nicolai crossed it. And Einstein was not willing to cross that line. And in that sense, he was defensive by By 1929, he gets interviewed in Berlin by a reporter for the New York Times. And as the reporter is leaving, the reporter asks, "Professor, I meant to ask you this. What is, is there a formula for success?" And Einstein says, "Yeah, if A is success, then it's equal to X plus Y plus Z, in which X is work, Y is play." And the guy says, "And what's Z?" And Einstein says, "Z is keeping your mouth shut."
Whoa.
And Einstein repeats this trope several times in different formats to several people, and I can chart how, from early experiences, whether it was as a college student or whether it was as a professor in Zurich or a professor in Berlin, he got in trouble with people for speaking his mind. So of course he wants to speak his mind, and he values his independence, and he wants to be a free-thinking, original thinker. Like he doesn't want to be quiet, but there's so many negative consequences. By the time he's super famous, and of course everyone is exploiting anything he ever said and misrepresenting it, then he says, had I known that everything I say would become newsprint, I would have retreated deeper into my shell. So he's full of this regret that every time he says something casual, suddenly people want to, put it on the front page of a newspaper or want to make a big point out of it. So yeah, he's a hesitant, I don't know, he's like a hesitant pacifist or a hesitant public speaker. Time and again, people ask him to join public causes, and sometimes he joins, but many times he doesn't, just because he mainly wants to work on his physics. That's what he with this thing, with being the designated speaker for causes that he didn't invent. At one point, he tells Zionists, he said, you can use my name for anything you want. If you want, I'll sign something, but please don't make me say anything. He doesn't want to talk. He doesn't want to talk. He gets in trouble. And, I'll give you a funny one. At some point, he says he comes to America, and then he says a comment to a reporter that in America, women run the house and the men obey the women. And and that people are super bored in America. It was distinguished in America as they're super bored people. And then Americans have a reaction, especially American women. And then he gets in trouble. He's like, Rome owes a lot to its cackling geese. And so it's like, even when he's trying to fix it, he puts his foot in his mouth. So Einstein's easier for people as a hero once he's dead. Because once he's dead, people can just look through the Einstein's corpus and find whichever Einstein thing they like and cite that one. But when he's alive, he'll say something. It lands in the newspaper, and people say, this really bothers me. Einstein should just shut his mouth. Famous pacifists would say Einstein should just shut his mouth. Because, for example, when World War II begins, Einstein, the pacifist, suddenly tells newspapers, well, German people are suffering of a mass psychosis, and they're basically crazy. And if I were Belgian, I would happily put on a uniform and get ready to go to war. So that's not a normal, I'll say that again. So
it's not a pacifist position.
Yeah, that's not a pacifist. So people get deeply annoyed. Here's a guy who says he's a pacifist. He's telling the Belgians to pick up rifles and put on uniforms to go kill people. And they say, Einstein knows a lot about physics, but he should shut his mouth about everything else. So again, to me, it's not just interesting that he gets into these things, but there's something comical. There's something very human in this struggle to, I guess I can speak freely now. I'll give you another one. Max Planck. When Einstein starts saying these things, Planck is still in Germany. So he writes to Einstein, and he tells him very wisely, what you're saying isn't helping people here. The value of an action should be judged by its consequences, not by its intentions. In other words, Einstein may feel that he's helping Germany by criticizing Germans and criticizing Hitler. But for the Jewish people in Germany, they felt that Einstein was putting them in danger, because Einstein is saying things that are like, oh my God, this is how dare, our most famous Jewish person is portraying Germans as crazy. Now the Germans are going to be angry at us for what he said. So Einstein's wife at the time, Elsa, put in writing that they got more hate mail from Jewish people than from Nazis. So imagine the reality. We imagine Einstein's a saint, and no matter what he says, everybody loves him, like your beloved grandfather. And in fact, he's upsetting people on the Jewish end of the spectrum, and he's upsetting Nazis. And so Einstein, whenever he hits against these like political issues, he feels very uncomfortable that things tend to get worse, not better.
I love that the times for Einstein are not that different from the Twitter mob of today, where no matter what you say, if you are a popular figure, that there will be a mob on one side that gets upset with you and the mob on the other side, and they will coalesce over the fact that you have not necessarily always hewn to the party line that is preferred for the saintly position that they have put you into. But with Einstein, so this is something that's always fascinated me, which is, how does like a knobbly, strange-looking physicist become this kind of figure for people? What is it about physics that just makes people lose their minds and decide that they're going to canonize this guy?
I'll give you his explanation first, and partly because I agree with it. The normal explanation is that he was a genius. There are very few geniuses. So yeah, this is not his explanation. But the normal explanation for most physicists and history people and just normal people, he was a genius. He made these great breakthroughs. So of course, he deserved all that fame. His explanation is very different, which is the media is systematically misleading people and giving him far more fame than he deserves. That this is a disaster, and he suffers a lot, and that he doesn't deserve all that fame, and that this is a kind of mass psychosis. And he puts it to historians as follows. He says historians should study mass psychology so that they can analyze how a random person who works on abstract physics is taken by the mob and converted into this paragon of things that he's not. So, for example, if you look at the equations of Einstein's specialty of relativity, of course, and you compare to the equations of Poincaré and the equations of Lorentz, which were in print before those of Einstein, this is very similar stuff. Like, it's a slightly conceptual change happening here, or you compare Einstein's theory of special relativity to Maxwell's equations of electricity and magnetism, as formulated by Oliver Heaviside. You look at that stuff, you think, well, obviously Maxwell's equations are far more important to modern life than Einstein's relativity. And the main virtue of Einstein's relativity is precisely that it helps us use Maxwell's equations. So to Einstein, it's very obvious, like, why is it me? Why are all these people so because of these incidents, for example, his first visit to United States, when he sees thousands of Jewish Americans waiting for him.
What year is this? Do you know?
Superstar.
Ballpark.
1921 or 1922.
Okay.
Yeah. So he goes with Chaim Weizmann, and part of the purpose is to do fundraising for what is to be the Hebrew University in Jerusalem, or at some level for Zionism, which Einstein still sort of believed in at the time. When he's basically taken by people who need him and who welcome him as an intellectual hero, but he doesn't want that. He thinks it's excessive, that it's just disproportionate, the attention he's getting. So long story short, what is it that happened? And the main answer is the Eclipse expedition of 1919, as portrayed in newspapers such as the New York Times and many magazines and newspapers in Berlin and elsewhere, conveyed Einstein as a historic genius, a new light in the history of humanity. And from that moment on, people are like, yeah, that's Einstein. More generally, I think there's something in American culture in particular having to do with a desire to identify people with a high IQ, people who are geniuses. These kind of intelligence measurement concepts were on the upswing. So Einstein came in at a good moment to fit him into that role of someone who does everything great and whose every word we should hang on, because it's such a precious bit of wisdom. Anyways, but you can see it's what are your impressions, guys? I mean, what is it that is there something that stands out as uniquely inspirational or magnetic about Einstein that might be what, at least in America, made him become so famous? Because it was, at some
Yeah, in
level, it
some
wasn't
sense,
a theory. People couldn't quite understand the theory. So go ahead.
I think that's actually an important part
yeah,
of
that's
it.
really, really important. And
Mhm.
I think that we can't talk about this story without bringing in Arthur Eddington as well, because Eddington, I believe Eddington translated some of his works for the English-speaking audience, and he, more importantly, championed that expedition to confirm Einstein's ideas. And he really had his hooks in the popular press at the time. It's hard for people to understand how famous Eddington was, or like how important he was. Kind of like Neil deGrasse Tyson and Carl Sagan rolled into one dude, basically. And so he kind of seems like took Einstein as a personal project. And I don't know, there's this other current too that runs parallel to this, and it's been a number of years since I read Einstein's original writings. I got really into it in my 20s. But I remember him having a bit of this lament towards the end of his life with respect to the way that other physicists had kind of run off with his ideas. And they were attributing a lot of the strange, spooky effects, especially when it came to, the Schwarzschild solution to the Einstein equations and some of these unreal effects, that people were running away with those a little bit. And you see the same thing happen with just famous people in our day. Like, there's I don't know if you've seen the movie about Dylan, Don't Look Back, I believe it is, but he talks about just, it's kind of the story of that fame
Maybe I did.
getting.
Actually, maybe I did. Yeah, go ahead. Yeah.
Yeah, it's
He
like the
talks about
story
the
of
story, yeah.
basically the fame getting away from him, and
Yeah.
he gets to this point where people everywhere he goes, they feel like they already know him. They have this idea of what they expect him to say, and he just gets to the point where he's just like, like, you can have Bob Dylan. Like, I'm just gonna be myself. Like, please just take that and leave me alone. Like, you don't even need me to say these quotes because you already know what they should be. And it's just this really interesting. I highly recommend it as a real good case study in how this kind of thing can happen to a person, where their public image, becomes its own almost living entity in the world, and they're sort of just existing in the background of that because the press and popular imagination has kind of run off with it. So I don't know, that was a little
Yeah,
disjointed.
I think you're spot on. I'm not entirely sure if I saw that one, just because the titles, I've seen several documentaries and things about Dylan. I get a little tripped up now, but definitely in one of them, Dylan makes clear that that he was not essentially an activist. And people like Joan Baez are trying to take him and say, look, we need to go do this protest. We need to go to this event. So she wants to do a protest. He wants to do Carnegie Hall. And so she's very upset that the main problem in society is the passivity. What I'm talking about at some level, people's inability to just speak up and say what they want. She says that's the main root of the disease. And at some level, Dylan is in that spectrum. In other words, he's an artist and he becomes the voice of a generation, but he's not trying to really be a revolutionary or to. So when he goes places and he says things just like Einstein.
Pardon the interruption, dear listeners, but we must ask you for a favor. If you like what the Demystify Sci podcast does, consider coming over to our Patreon. It is at patreon.com/demystifysci, and there you can contribute a couple dollars a month to help us keep the ship running and allow us to continue our investigations into the most interesting ideas that are out there about nature, humans, history, the future, technology, economics, all of the things that we do on the podcast. In return for your donation, you get both of our episodes for the week early. You get to join our fantastic patron chat that meets weekly on Sunday mornings to talk about everything that is interesting in the world and the direction that the podcast should take. And you get to have the satisfaction of contributing to something that you think is important in the world. If you can't contribute right now, that is totally fine. We understand. I have been in that boat for many, many years. But what you can do without spending a single penny is come to our Discord, come to our Facebook, come to our Twitter, come to our Instagram, like, comment, and subscribe, because by helping us with the algorithm, you help us grow in a really super passive way. And if you've already joined the Patreon, just do all that other stuff too. For now, back to the conversation.
He does get in trouble. Because suddenly he starts speaking his mind, and people are like, "Oh my God, what he said! He should apologize." And he starts withdrawing. I don't want to talk. I'm just gonna sing my songs. Now, going to your first point about Arthur Stanley Eddington, that's really great. I think that's spot on. I hadn't heard it quite that way. But the reason I think it's spot on is because of the general framework, which is discoveries in society require two parts. One is the person making the discovery, and the second one is the person who discovers the person making the discovery. You can write a book, and it can be a great book, and nobody cares. Nobody will care. I mean, it will make no difference in the history of idea. But if Oprah recommends that book, that's it. You're suddenly a superstar and a multimillionaire, and your book will be translated into 14 languages. And it's interesting that certainly, yeah, Eddington was just a towering, famous popularizer of science. He wasn't just a Quaker who didn't want to go to war. This is a very, I don't know, well-educated, cultured guy who knew how to play the media. So yeah, to a great extent, him and say statements by J.J. Thomson, but especially Eddington's role in it, that is in the English-speaking world. It's the English-speaking world. Because yeah, Einstein's featured in some Jewish magazines in Berlin, but it's a byproduct of the fact that the English-speaking media has trumpeted this achievement. It's a slight deviation in what the Einstein makes a version of Newton's theory, and that version predicts deflection. Then we compare that Newtonian Einstein version with Einstein's general relativity, and we find that Einstein's Einstein beats Newton's Einstein. Okay, of course, the guy formulating both theories will choose the better one. And so it's but it's still, strictly speaking, Isaac Newton did believe that light consists of particles. And strictly speaking, Isaac Newton did believe that when the sun emits its particles of lights, it is losing mass. And strictly speaking, we can derive from Newton's theory the fact that light should be attracted by gravitational fields. So none of that is that radical if one tells the story properly. So there's a difference of degree. That is, the deflection of starlight has a slightly larger curvature in Einstein's general relativity. So it doesn't necessarily need to be a big splash in the history of humanity, but it does become, partly because very rightfully so, people are inspired by the idea that Newton is wrong, which I think is great. I think whenever we can discover that some great scientist was actually wrong, strictly speaking, just mistaken, or that in the simplest way, his equations of gravitational force do not have a parameter accounting for the delay in the gravitational force as it's transmitted from one body to another. Einstein has an upper limit, like speed of light. So in that sense, Newton is just wrong. And so I think that's gripping, that Einstein becomes this agent for people to actually enjoy the reality that scientists can be mistaken. But of course, society cannot tolerate that. So soon enough, Einstein and so many other people, they go to the story of, well, Newton isn't quite wrong. It's just that within a certain range of blah, 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 there's some slight deviations. And so then they try to minimize what are really conceptual revolutions. Similarly, special relativity, strictly speaking, just shows Newton is wrong. But countless teachers and physicists do not want to teach it that way, because again, it would show this combative, confrontational version of the history of ideas, which they can't tolerate because they'd rather think it's all bricks. And Galileo put a brick, Newton put a brick, Einstein put a brick, Maxwell, and they just like to think that it's this architectural nonsense, which is not what's happening. And that's the fiction they sell, and which stops anyone from questioning. If you think that Newton is always right, and that Euclid is always right, and that Einstein is always right, of course you can't do great physics, because you've been brainwashed into thinking that the geniuses were born hundreds of years ago, and it's too bad.
Yeah, I think it's really too bad, because the deeper you get into physics, the more you realize that there's just fantastic gaps in our understanding that require tons of attention. I mean, the only reason I didn't do my undergraduate in physics is because it felt like something that was already sewed up and done with. My roommate at the time, he arrived at college and he already knew what he wanted to do. He wanted to become a neuroscientist, a cognitive neuroscientist. And it just seemed like we were going over class schedules and stuff, and it just seemed like a much more promising discipline to get into. And I ended up majoring in it myself too. And I didn't get back into physics till grad school because I just was under this impression it was all done already. Yeah. And that's a real tragedy. And the bigger tragedy underlying all of that is that science does involve the toppling of these walls from time to time. Like, that's a really important part of science is, hey, sometimes we're wrong. Not only sometimes, but we're predictably wrong. We have to be wrong in these things. We don't have the whole picture ever, really. And sometimes, periodically, regularly, we have to knock those ideas down and move on.
It's almost like there's a whole genre missing, which would be called something like the history of mistakes. Like we have to be able to admit that people like Galileo, Einstein, and whomever were exceedingly frequently wrong. And instead, they just don't teach that. And I was mentioning that it's religious thing, because it's almost like science copied the teaching mindset that was common in theology. In other words, we're going to portray the great writers as saints. We're going to describe their labors as miracles. That's why countless people will talk to you about Einstein's miracle year. They think that they're saying something cute. They're not. What they're saying is parroting a mindless, nonsensical line from the Middle Ages, as if it had any bearing. To Einstein, it's plainly nonsense to say something that's silly. But the people just get a little kick out of it because they really want to believe that Einstein's like Harry Potter, that since birth, if it's not a little lightning bolt on his head, it's a weird brain that maybe if you dissect it and cut it right, you'll find that there really is something different in some part of it. It's so sad because, again, what we're doing is we're driving people like you out of physics. So anyone who's a bright, independent thinker who actually asks why will quickly feel, A, I'm not getting the answers. B, I'm not getting the honesty. Because a professor could just tell you, I don't know, that's a great question. Maybe you're right. Let's do something. Let's brainstorm. No. They can't stand it. If you actually start bringing up objections to whatever it is, they'll feel very uncomfortable. Why? Because that's the method from theology. Here's a doctrine. You're supposed to learn it and shut your mouth. You have to shut your mouth. It used to be until you're a graduate student. Then it became, you have to shut your mouth until after you're a graduate student. Now shut your mouth and work with your professor and 6 other students. Publish a few things, then you can talk. And then it became shut your mouth and work as a postdoc for a few more years with another mentor. Then it became shut your mouth while you're an assistant professor because you got to get tenure. So by the time someone gets tenure, they've systematically shut their mouth as an undergrad, a graduate student, a postdoc, and an assistant professor. We're talking about maybe 15 years of life in a university. So by then you get these, say, faculty council meetings. Are people going to talk? Of course not.
I mean, what I've encountered more than
maybe into shutting their mouth. Go ahead.
Oh, just more than being told to shut my mouth, I'm usually told something like, that's not something that's not what we study here, right? Like, Anastasia famously had this case where she was studying the electron transport chain in her PhD.
And it was really interesting because at some point I was writing my thesis and I realized that I didn't have a good sense of what charge meant.
Of course you don't.
Right?
You don't.
But I was like, I'm a stupid biologist and I don't understand. And so I was split between a biology lab and an electrical engineering lab. And I was like, I can't write this without understanding what is happening to the molecules when they're carrying charge. And the rabbit hole that I went down ended with, it doesn't matter what is happening. We're tallying the motion and we can put the plus sign or the minus sign and that is sufficient. And when you go and you talk to electrical engineers, because that was half of who I was spending my time with, they're kind of like, who cares? Like, we have an equation that works for it. Like, look at the stuff we're building. They were building, neural shanks to input into rat brains to measure the activity of neurons and to be able to control it. They had like $30 million DARPA grants for producing all of this stuff. They were doing fine without ever once stopping to ask, what is the nature of charge? And so it's perfectly reasonable for them to be like, what the hell are you asking? Like, why do you care?
And it's especially ironic because we then became, I was teaching some physics courses at the time too, and I was also growing concerned that there was a number of fundamental questions that were just not on the table.
Well, I remember one night I came home and Shiloh was like, I don't know how to explain magnetism to my students. Like, I don't know how to explain what a magnet does.
What the atoms are doing, right?
Yeah.
And so it's really ironic because we spent many years obsessing over these questions and coming up with material models for what the atoms could actually be doing. And the funny thing is, like, we tried to write some papers and some blogs and stuff on this, and we'd go someplace like a public forum, like you'd go to Reddit and you'd go to R Physics and try to post about these kind of topics. And like the blogs that I wrote about it, they were just killing. Like they're cruising up the Reddit track, and then all of a sudden the moderator steps in, rips the article down, and tells me that this is philosophy, not physics. So I go over to our philosophy, post the same piece again, skyrocketing up the ladder, and then boom, pulled by the moderator. Moderator says this is physics, not philosophy. And so it's this hilarious like blank spot where it doesn't fit into the traditional canon of the physicists. The philosophers don't really have any interest in tearing apart physical ideas because they figure that's what physicists are doing. And nobody's really doing it at the end of the day. It's like everybody thinks everybody else is doing it.
But so this actually traces back much before Einstein. So we're working on a book right now about the nature of material physics. And there was a very, very brief moment in the 1600s when René Descartes was writing. And Descartes was like, hey, I think it's a mechanistic universe. And I think that the only thing is these divisible. He didn't want to call them atoms because atoms were by nature indivisible. And he was like, so there's these.
Let's say bodies.
These bodies, and the bodies are in motion, and the bodies are touching each other, and the surfaces interacting is the thing that gives everything in the universe its form, shape, tendency, everything. Like everything is mechanistic. And within 50, and this was for a brief moment very, very popular, but nobody could demonstrate a mechanical experiment that made the vortices possible. Right, so everybody they would like fill barrels with fluids and roll them around and try to make it so that they could demonstrate how the vortices could be responsible for the motion of the planets, and nobody could do it. And then Newton comes around, and Newton's like, "Hey, I've figured out this equation. This equation accounts for all of the motion, and the plenum, which is the filled universe where everything is touching everything else, is impossible because it would create too much friction. It would slow everything down, and you would eventually have no motion whatsoever." And so Newton was the one who codified this idea of bodies being able to interact at a distance without a mechanistic intermediary. And
yeah, he wasn't like, that's a bad idea and I have a better idea. He was just like, that's a bad idea and we're not going to worry about this kind of thing anymore.
He has this addendum to the Principia, which is called the General Scholium. He adds it after he's done his optics work and he's come up with his corpuscular stuff. And he's like, you know what? The job of the experimental philosopher is not to make hypotheses. It is not our job to figure out how this is possible. It is our job to come up with a mathematics that describes how it is. And so there's only this little brief window where people are really preoccupied with mechanism. And so when we say that Einstein overturned Newton, I feel like he overturned Newton only in the realm of the mathematical toolbox that people were using, because he invented the tensor geometry that's necessary.
He implemented it, yeah. It was developed by another guy.
And that's exactly the same thing with Newton, right? Because people argue about, did Newton invent calculus or did Leibniz? But at the end of the day, it's like Newton applied it most efficiently. And that's why everybody credits him with it, because he had this entire body of work where he was like, well, look, this is all the ways in which the math works. And Leibniz didn't have the same corpus of ideas. But all of this to come down onto the fact that something happened with Einstein that was not a change in the nature of how we think about physics or the material universe. It was simply a transition to a new form of it. It needed to be updated because Newton was too old-fashioned, I think. They needed something for the new century.
It's also just I'm sorry to just keep ranting here, but I think it's worth being said that Einstein's general theory of relativity can be boiled down to realizing that inertia and gravity are the same thing, and taking Newton's basic inertial and gravitational relationships and making them equivalent to one another, and you can essentially deduce the entirety of general relativity with a few other assumptions from that basis. So in some sense, it is a continuation of that tradition, but it just like Newton was not really preoccupied with material cause and effect so much as patterns of action.
Yeah, and let me interject.
Yeah, of course.
several great points. I wrote some notes here. So first to the issue of what you just mentioned, which is the transition from Newton to Einstein. There was a big loss in the collapse of the mechanical philosophy. In other words, the mechanical philosophy meant we can break things into parts. We can pinpoint those parts. We can disaggregate them. We can trace them in space and time and their interactions, and we can visualize it, and we can chart these transformations. Once Newton takes some steps away from that, it's unfortunate, because then most physicists then took that as almost intentional or ideal, when in Newton's case it's a bit of a failure. In other words, Newton himself knows that it is absurd, as he writes in at least one or two letters. This is absurd that one body with no mediation actually acts on another body in enormous distance. So he says this is completely moronic. And what he knows he has are equations that describe the rate of those actions, but he considers different mechanisms, just as Descartes did. So it's as if the equations are a framework for analyzing mechanisms. Is it that something comes out of the center of the earth, rises up, and through convection pushes things down? Or is it pressure from things in space pushing down? So Newton is aware that there is a deficiency in his physics, but that awareness is lost, partly because he's too harsh on people who had made hypotheses, people like Descartes. In other words, some people imagined a little too much. For example, Descartes sees particles of light like tennis balls going through a net and stuff like that and bouncing around. And Newton is annoyed. Once you start adding too many imaginary details to things, he starts getting annoyed with that. But
it seems a little bit apologist, like almost like he's kind of, I get the impression, this is pure speculation, but I sense that he was a little disappointed that he wasn't able to solve that mechanistic issue. And so as a sort of like cover up for that embarrassment, he just asserts that we shouldn't even bother with it. He's like, it's not our job anyways. Like, I can't figure it out, so don't worry about it.
Newton is strangely pissed off at Descartes. It's an outstanding problem. I've never read a paper explaining clearly why is it. But for example, Newton says, Galileo's principle of inertia, objects in empty space move in a straight line. Galileo never said that. Galileo claims that in space, objects move in circles and that the fundamental natural motion is circular. So Newton does weird things like giving credit from things that Descartes has said, like uniform rectilinear motion, to Galileo. And Newton, who had been deeply influenced by Descartes' work on optics and on method, then he acts as if Descartes is just some embarrassment. So, but what I was getting at, which is the loss, is that Newton recognizes that the job of natural philosophy should be to look to the causes. Of things, but because he's so annoyed by the medieval philosophy of hypotheses, conjectures, guesswork, and imaginary properties, he takes a hard stance that hides to the reader the fact that in Newton's own manuscripts, when he first wrote about the laws of motion, he called them hypotheses. In other words, Newton himself is using hypotheses and then disguising them as fundamental discoveries about the nature of the world, which is absolute nonsense that was devastated, for example, by the mathematician who influenced Einstein, Henri Poincaré. To Henri Poincaré, it is painfully evident, as he explains, that Newton's second law of motion is a convention, it's a definition. In other words, there's no discovery here. What simply has happened is two recurring variables, the mass and the acceleration, are being multiplied. And whenever we multiply these two variables together, we're going to call that a force. That is what the second law, it is a definition. And to this day, there are physicists who deny that, who don't understand that, who write papers about it, who proudly pat themselves in the back for allegedly understanding that this is a great discovery, the reality of force and the discovery. And Poincaré says, look, this is just a definition. The law of inertia is a concept. In other words, an object left to itself moves in a straight line. Physicists and astronomers have never seen anything move in a straight line ever. So imagine the fiction. Everything moves in curves. Satellites, meteorites, comets, asteroids, planets, suns, galaxies, everything is moving in curves. human bodies, anything that happens in a straight line on Earth is happening on a spinning system. So we have never seen a straight line. Yet they say that if we remove everything from the universe, every single thing were to suddenly disappear, then things would move in a straight line at a uniform speed forever for an infinite distance. All of those 4 or 5 things are fascinating, but they're little fictions. We've created this. The proper word for this is metaphysics. We've created this fantasy, which is lovely, in order to teach students that the world is very simple, and that, but what we're basically doing is taking a curve, such as the curve of the moon around the Earth, and breaking into rectilinear vectors, because we think it cannot just be a curve; it has to be one line.
Yeah, and one of those rectilinear vectors,
and then
one of those rectilinear vectors, that this idea of the force of gravity. I mean, actually, just forces in general. I've never actually heard anything more superstitious in science than the word force. Like that's
energy.
Literally the stuff of science fiction. Yeah, energy. Okay, fair enough. Okay, you got it.
Let me
go ahead.
Rattle off a few comments in connection to what Michael raised a few moments ago. One of them was this problem in physics. In other words, the reason people were demoting you and removing you from these platforms, you were trying to find conversation spaces where you could just talk. And people were liking your comments, and some jerk steps in, calling himself a moderator. Well, I decide, I'm the gatekeeper, and I think I don't like this because it doesn't sound like what I already know. So you seem to think that you can have ideas. Ideas are not allowed. Why don't you go some other place with your ideas? I think this pertains to what Karl Popper described formally and seriously, the philosopher, as a crisis of understanding. That if modern physics is in a crisis of understanding, in other words, once quantum mechanics comes along and people adopt this mindless view that what matters is only the mathematics, which of course it's mathematics that they don't understand. They can't express it in language, they can't express it in pictures, they can't express it in cause and effect, they can't express it in models, and they can't express it in logic. What matters is just the mathematics. And for example, one electron can go through 2 slits, or one object can be in 2 places at once, and then it vanishes, and the sphere had expanded and it was as far as the orbit of Jupiter, but then it collapsed and suddenly it's here in our living room, the collapse of the wave function. All of these bits of nonsense began to thrive because accidentally physicists backed into a corner, which is mathematical literalism. In other words, once they had abandoned the other modes of knowledge that can step in and say, hey, you know what, maybe the math is wrong. Or maybe what you're calling a law is not a law, it's a definition, a convention, or a hypothesis. Once these other or philosophy, physicists pat themselves in the back so often for thinking philosophy is trash. And above all, philosophy of physics is trash. So these people, once they had stripped away so many things, then they were left with this mathematical ambiguity. And unfortunately, then in comes the intolerance. Oh, you don't agree with the mathematical laws that we have, then there's something wrong with you. Oh, you want something more than the laws, like a model or a cause and effect text or new words? You want to change the words we have? Like Niels Bohr would say, you cannot change the language of quantum mechanics. It has to be the language of classical physics, which we know is obsolete, but you can't change it. You shouldn't try. And if you try to change it, there's something wrong with you, because you have to just give up and renounce the effort to understand. Now, Niels Bohr is a guy who again and again used the word, we must renounce the effort to understand the quantum world in terms of pictures. In other words, do not try to do a model of the atom. Niels Bohr failed, so will you, so don't try. He said, we must renounce.
So weird.
This is a disease. In other words,
it's not that weird, you guys.
Problem.
You guys, people go to Latin Mass and they go and they listen to people saying things that they don't understand because it gives them a spiritual experience. And I don't think that that's an incidental or accidental process. I think that it speaks to something that is fundamentally necessary for humans as part of their spiritual well-being, to have something that is almost impossible to wrap your head around, that puts you in a position of smallness in the universe, where there is some class of people who understand. You are not one of them, and it places you in a cosmic hierarchy that is on some level comforting. And that rose at the turn of the century right as religion was going down. And it
Yes.
also rose at the same time that mass media first came online in a way that was very, very effective at transmitting these ideas to massive numbers of people at the same time. And so I look at it and it's so transparent that it is the motion of a deep human desire from one superstitious system to another superstitious system,
Yeah.
which is codified in the language of the age, right? Like mathematics and quantum mechanics and atomics and everything that came out of that is the manifestation,
Especially electrodynamics.
and quantum field theory. Like these are all
Very esoteric mathematics.
yeah.
They're vessels for people's desperate craving for confusion and mystical non-understanding. And I totally agree with Anastasia. What you've diagnosed is, I think, simply correct. In other words, there's something with the rise of secularism, whereby many people who had stepped away from religion, whether it was partly or entirely, still felt a craving to feel there's something weird, magical, mystical, spiritual. And where do they find it or place it? In physics and math. So, and they love that physics and math, as they presently stand, provide them with some seemingly amazing miracles and mysteries, and above all, unsolvable mysteries. Thou shalt not try to change or get rid of the wave particle reality. Duality. Thou shalt not try to change Einstein's general relativity. Thou shalt not try to get rid of dark matter. It's thou shalt not try to come up with a different explanation for the redshift. these things are so pervasive. So I do think the way you're answering is correct, which is these people, these things, these attitudes do not survive because they're unintuitive. They survive because they're satisfying. And there's a fascinating letter from Einstein's younger son, Edward. I think it's 1925. So this is before Heisenberg's uncertainty. And Edward says, I think people love uncertainty because it makes them feel good. It makes them feel good not to know and to be kind of there. So there's something that once someone kind of diverges a bit from the feelings, the fulfillment that religion can give you by giving you its mysteries, then they tend to embrace the mysteries in physics. And at some level, that's fine. Mind you, I don't mind that people do physics as they want. If some people, what is crushing to me is that there isn't even a 5% group where there are people saying, let's make a model of the atom. Let's just do it. Or let's explain what charge is. Let's just do it. Or let's change physics so that we no longer say nonsense, such as current always flows from the positive to the negative. I mean, why can't they just say,
Man, I'm really excited to share our book with you. I'm really, really excited. This is exactly what we're trying to do. I mean, nobody will read it probably, but
I'll give you an example. Me, myself, when I'm done with my novel about Einstein, I want to write a physics book. Because originally that's part of what got me into history of physics. I wanted to look at the real thing. What is gravity? What is really happening? Rather than just, well, I now understand that there is nothing to be understood in quantum mechanics. I mean, these people literally have said this nonsense for decades. Freeman Dyson said, you graduate students, it used to be really difficult in print, really difficult to break them down into accepting quantum mechanics. Every year, it becomes more and more easier as we get new generations of students, and eventually they understand that there is nothing to be understood in quantum. In other words, they don't even see the mystery. It's all the Schrodinger wave equation, the paradigmatic examples we've been given, and what's the problem? Well, then instead of having thoughtful physicists, what you get are handbook engineers. They're just people. These handbook engineers take the rules. They think the rules are correct. They think bright minds have already looked at everything and have confirmed that Maxwell's equations forever, Einstein's gravitation forever, quantum mechanics forever. These are forever things. And the best we can try to do is marry them a little bit better, building bridges with invisible, super complicated mathematics. All of that is, I think, silly and sad. And it wouldn't be the case if people just understood the history, which is you need irreverent people like Einstein. Now, Einstein is what we would now call a crank. I mean, he meets a guy at the patent office who tells him, I have a PhD in physics from the Polytechnic. I publish in the Annalen der Physik on electricity and magnetism. Would you like to look at one of my papers? The guy tells him that, Joseph Sauter. You know what Einstein replied? He says, I'm not interested. I'm a heretic. And the guy, is surprised and says again, we really should talk about Maxwell's theory and models of. And Einstein says, I'm a heretic. And the guy, 50 years later, recalled how strange it was for this college graduate, this graduate of the Polytechnic to say he's a heretic. So Einstein remains a government worker for, 1902? Yeah, 1902 until 1909. We're talking about a 7-year period in which Einstein, who we now regard as this famous guy, is basically an amateur physicist working from home. I mean, and for part of that time, he didn't even have a PhD. What he had was a degree for teaching science and math. So in other words, time and again, we have discovered that amateurs can make contributions, and that is the story of Einstein. Do physicists teach it that way? Of course not. They teach him as a genius. He's an outsider. He is an outsider who calls himself a federal ink shitter. That's Einstein. And when he publishes the theory of relativity, he gets no job offers. And when he publishes the quantum theory of light, he gets no job offers. and similarly, the guy who formulated n-dimensional algebras, Hermann Grassmann, is a high school teacher. The guy who formulates the theory of a continental drift, Alfred Wegener, is a weatherman who had studied astronomy. He's a weatherman who studied astronomy and got shot in the neck in World War I. In other words, he's not a geologist. He's not a geophysicist. He's an amateur. Charles Darwin is an amateur. Charles Darwin never had a PhD. He was not someone who graduated with honors. He's a guy with a bachelor's degree sitting at home with a stomachache. That's all Darwin ever was. But because scientists cannot teach it, they just can't. It's unbearable for them. It's unbearable for them to think that outsiders can actually contribute something. Then they create all these things, whether it's ignoring Johnny's question in the classroom or removing someone from a discussion chat because it's just not the way they think. They don't think it's possible that some random person can come in and do something. And it's just sad. It's just really bizarre.
Can we change that? I mean, is that possible? Do you see it? Can humans evolve? Can we become?
I think some units, suppose there were some university, a small university in which they would do a small department where some sort of actual theorizing is allowed, where people can look at something like the law of inertia and say, hey, are there alternatives to a law of inertia? Let's just brainstorm. A place where that were allowed, I don't know of any such place, but in principle, it's just a little bit of money. $100,000. I mean,
we get pretty close because we teach at a small university, and so there's not really anybody breathing down our necks. Like nobody's really coming into my classroom, seeing what I'm teaching. But in terms of getting paid to do the research, that's kind of unimaginable.
No, I think that that Albert's right. Wait, Alberto, yes?
Yeah.
I think that Alberto is right, where it's important to have liberty and time, and teaching actually is kind of ideal because, yeah, you get paid a pittance to do it, but it's enough to have a couple of students that get interested and you can pursue the work with them. And there are probably pockets where that's possible, but one thing that really struck me about everybody that I've looked into that has had ideas is the degree to which they've had this super well-rounded education in classical thought. Mm-hmm. Right? There's a trajectory of analysis that seems to be important for someone who wants to change things, because it's rare that somebody with no background in any, whether it be like the Islamic scholars or the European scholars or the Indian scholars, like somebody has to have a background in thought to be able to trace back to a place to say, hey, I think they were onto something here. What happens if we elaborate in a different branch than the one that was followed? And so I think that as long as you can get that kind of classical background, whatever shape it comes in.
In that context, Einstein, for example, thought that it's necessary to teach the humanities, and in particular to teach the history of individuals. So now notice how nowadays what has been the vogue for over 10 years is individuals do not make discoveries. It's groups. That just does not happen. That's a myth. And I think I may have even seen this title in one of your podcasts. I think somebody came to discuss this. In other words, they want to say, hey, you know what? Discoveries are only made by groups. Join the group, and we'll share the credit. But there are no lone geniuses. It's absolutely absurd and false. This is just not what's happening. Again, who is Alfred Wegener, the founder of Continental Drift? He's an eccentric individual. Einstein is an eccentric individual. He gets help from a few people, like who? Like Marcel Grossmann. Marcel Grossmann is, just not a famous mathematician. He's just a friend of his from college. In other words, Einstein's collaborator was explaining to him that, the methods of tensors and Riemann and that sort of stuff is the way. It's just a high school. This is a college friend of his, a buddy of his, who helped him study. And Michele Besso is a mechanical engineer. He's not even a physicist. And Besso is helping Einstein with special relativity and with general relativity. Besso is just a co-worker at the patent office. So, and I could keep rattling off example after example. Oliver Heaviside is the guy who really formulates Maxwell's equations about electricity and magnetism. They should be called the Heaviside equations. Why are they not called that? Because people are not interested in reality. They're just not interested in it. But what is the beautiful thing that we could learn? Well, Oliver Heaviside is a weird loner who retired very early from telegraphy. And he's just kind of an electrical engineer kind of guy. In other words, he's not a physicist. He's not a professor at a university. And he's a weirdo who lives with his parents and rides his bicycle and has kids throw rocks at him. In other words, at some level, he's just an amateur. He's just an amateur. But why can't people just teach this way? And I'll give you the biggest example that I actually do research on. So I've got this book about Giordano Bruno and Galileo. And before he died, at one point, I was having lunch with Steven Weinberg because he worked here at the University of Texas. And he said, what are you working on these days? And I said, I'm working on a book on Giordano Bruno. He said, why? Because he was annoyed. In other words, the guy has been trained by culture that Bruno is a weirdo, a mystic, and above all, a non-scientist. So I said, I bet you haven't read more than maybe one work by Giordano Bruno. He said, I haven't read none, and I never will. Now imagine, let's forget about Weinberg as an individual and think about the culture, which is Weinberg is a vessel for an attitude that was taught to him by culture. And the attitude says, which is echoed by countless people, it says, you know what? Kepler, Galileo, and Newton were real scientists. Giordano Bruno was a weirdo and a hermetic philosopher, and Calvinists, Lutherans, and Catholics, they all excommunicated. So he basically was a jerk and he deserved to die. This is a meme. This is just a cultural meme that was created. But if we look at a guy like Bruno, what was he really? He's a former priest who turned to philosopher, believed in Copernicus, and as an amateur realized, get ready, that Copernicus is wrong. 1, the universe is not a sphere. Bruno is right, it's not. 2, the sun is not the center of the universe. Bruno is right. 3, the stars are not separate, different bodies. They are suns. Copernicus does not even contemplate that. Bruno says the stars are suns. 4, the universe has no center. That's Giordano Bruno. 5, the stars are surrounded by planets. Nowhere does Copernicus say anything like that. 6, those planets are surrounded by moons. So in other words, when Galileo says, I have found moons around Jupiter, he is confirming Giordano Bruno, not Copernicus.
We are delighted to announce that Demysticon 2024, our very first scientific conference, is officially launched, and you can buy tickets right now at the link in the description and also in the link that is up in either this corner or this corner. We are going to gather in Austin, Texas on April 7th and 8th of 2024 for 2 days of talks on consciousness, mythology, archaeology, solar physics, hypnosis, and much, much more. Buy tickets now, up at this link.
When Galileo says, I have discovered innumerable invisible stars, he is confirming Giordano Bruno. Giordano Bruno said it again and again, there are innumerably many stars that we cannot see. So Giordano Bruno agrees with Weinberg 100 times more than Galileo or Kepler. And yet, what does Weinberg do? Says, I'm not even going to look at Bruno. So notice the extent to which these things, what are the valid questions? It's just shaped by culture. People think they're having an idea, and what they're actually doing is parroting some nonsense that somebody told them on a TV show or on a blog or something. But what would be cool would be to create some sort of place where people actually can distinguish whether they're parroting something or actually thinking. And if you can get that rhythm of having people, yeah, I realize that when I say that, I've heard it before. I'm not actually thinking. This is just something I've heard. It tastes good to me because it makes me feel like I know what Giordano Bruno is about when I've never even read one sentence by him. It makes me feel like I'm really getting so that would be, I don't know which university would do it, but as Michael rightly pointed out, the sad thing is the philosophers are generally not doing it either. In other words, philosophers became so intimidated by physics throughout the 20th century that they stopped criticizing it. They don't have the courage to say, you know what? I think these physicists are probably wrong about whatever, some black hole that they've invented somewhere because they have some cosmological observation that doesn't work. And if you invent a black hole of just the right size, just the right motion, and etc., then you can fix anything. Well, there's a black hole that's distorting that light so that instead of just saying, hey, our cosmological theories don't work, we've proved it. Instead of just saying that, they can always fill the universe with black, dark, invisible things, as many as they want.
You just turn they turn the mistakes into actors themselves, which is it's like a amazing sleight of hand. It's like the theory doesn't work, so we're going to turn the broken parts into parts of the theory. It's very, very perplexing. You wouldn't get away with that in any other science.
Other science, and then they congratulate themselves for having discovered. Now, I'm not saying that black holes don't exist, but they're certainly not what people originally thought they were. Oh, we have a mathematical singularity, the mathematical point, and it absorbs everything, but nothing ever comes out. Gradually, finally, scientists have acknowledged that's just not true. They do radiate and so on and so forth, but the basic idea that you can always put an invisible thing wherever you want, that's what Newton wanted to get rid of. Well, why is this green? Well, because it has a property of greenness. It has greenity. The property of greenity. You've got to get rid of this nonsense. You can just start adding things. Anyway, but I think it's cool that you guys have this space to talk to people and gradually find some people who haven't been totally brainwashed, because there is some brainwashing here. I'll give you a neat example. Murray Gell-Mann, Nobel Prize winner, he said that Niels Bohr basically brainwashed a whole generation of physicists into thinking the job of interpreting quantum mechanics was done. Louis de Broglie, who was one of those physicists and one of the founders of quantum mechanics, Louis de Broglie said it took him 40 years, he said it in writing, to regain his mental independence after what Bohr did to him. 40 years. Do you imagine that? You're a physicist, you're at the cutting edge, and they tell you, no, it's done. There's nothing you can do. This is what it is. And finally, he comes around and says, you know what? Maybe David Bohm is right. But because the orthodoxy in science imitates the orthodoxy in religion, then people cannot quite be scientists. So they say, okay, I'm a scientist. I'm a free thinker. But what they're doing is they're giving themselves a word, which is an award that sometimes they don't deserve. What they are is a handbook engineer, which is fine for building bridges, but it's not science. In other words, you can be an applied scientist with dignity, but if you think that you're on the cutting edge, that's just not really what's happening. What you're doing is parroting things that were written by people who we think were touched by God. And
something that we've come across a lot with exactly that mindset is how difficult it is to study something that is A, unseen, and B, mathematically defined in a way that is super functional. So if you take that everyone is a handbook engineer, or not everybody, but let's say a lot of physicists are handbook engineers, then what they're doing is they are operating in a paradigm that is functional for taking the next step. Like you always see people
technologically functional,
and you always see people say like, oh, the standard model of particle physics, incredibly predictive, incredibly effective. we're super far along the path towards piecing all of these things together and understanding exactly how they fit together mathematically. And I'm like, I think that they're right about that. And there's a lot of noise about, how a lot of people try to recreate the mathematics, and they argue about, the particle physicists are wrong for this and that reason, the mathematics are wrong for this and that reason, and it's the same sort of, like you said, the same sort of heretical mindset that probably formed Einstein, but I'm very skeptical about it because it does have really good predictive power. Like the math of general relativity, very predictive. The math of the standard particle physics model, very predictive. And so I wonder if the next phase of people breaking through this engineer's handbook is not about figuring out better systems of mathematizing concepts, but actually stopping to answer, what does the math mean? Because what if we've just gotten to the end of like what we can do with a reasonable amount of money? Because you can build a bigger collider, you can go one level deeper in standard particle physics. Like I saw a headline that they were like, we need $22 billion to build the next level of collider. That's 10 times bigger than the LHC in order to be able to probe the next level. And I'm like, but you probably already know what you're going to find down there, but you don't know what it is that you're finding. Like you have no model that brings it all together. And I feel like the heretical shift that needs to happen is a metaphysical.
It's on the interpretive level rather than on the rather than on the quantitative level. I think that's really what it comes down to. I almost feel like as scientists, we've atrophied that part of our imagination as a class. Like we've been so concerned with the quantitative refinement of the description of what is happening. In other words, building better and better maps, that we've stopped being concerned with what the maps are actually saying about the landscape. And we don't have those muscles left anymore, like, as a scientific, group.
Yeah. Like I started studying biology because I was fascinated with the nature of life. I was like, I will study biology and I will understand what life is.
Yeah.
My friend, let me tell you.
Go ahead.
That is not what you get at the end of biology.
Yeah, that's the cheat. In other words, and this is the same reason I'll talk to two of these things. One of them, Erwin Schrödinger, when Bohr and Heisenberg twisted physics into the weird thing that it now is, he said, if this is what you guys are going to do, then I'm leaving. And what did he see? He said, okay, I'm going to biology, where at least reason and the urge to understand causes and what is life and nature. So Schrödinger leaves. De Broglie is shut down. Einstein's converted into a heretic again. Einstein says, these people, they pull me out at events like a mummy, like just an object for show and tell, but he thinks they don't respect them. So the orthodoxy is formed very quickly, 1927 to 1929. This thing is formed and there is no more questioning allowed. Just accept that there's nothing to be understood in quantum mechanics and that reality is fundamentally contradictory and so on and so forth. So there's the hope, or there used to be, that if someone wants to find reason, then you can leave physics and go to something like medicine, biology, maybe even sociology, and you can get interesting results. But the sad thing is that the damage that is done to physics by shutting out people like Michael is that. And I mean, when he was considering studying this as an undergrad, Michael, you said that you were going to study, but they gave you the misrepresentation, which is physics is done. Now, that is the exact misrepresentation they gave to Max Planck over 100 years ago. When he considered Planck physics, his advisor told him, physics is practically a done field. This is a finished field. And imagine what nonsense it is to tell someone that in the 19th century. But that is, again, how physics gets misrepresented decade after decade. It's, if we can just not allow you to ask the wrong questions, then we can sell you the idea that we're nearly done and that we know almost everything, which again is a pattern from theology. And I think it's good business if someone in theology, you want to have members and they want answers, you can tell them this is the answer or there is no more answer, but these are the answers. Just take them down and stop asking questions. But for science, it shouldn't be necessary. There should be at least 5% of science, physics, that involves people saying, I don't know, this is probably wrong. And the fact that the theory has worked for 100 years doesn't really mean much because other theories have worked a long time and have been abandoned in one context or another. That's one thing I want to say. The other one is just about
Can I respond to that really quick? Just because I think it's really, really interesting that I found my way back to physics through biophysics, because biophysics was actually the domain where mechanical processes were still being examined. And in a physical landscape, still using physical equations, the only difference between us and the proper physics department, although we were in the physics department as well, but we were also in the biology department, the only difference was that we had material substrates for the actions that were going on inside of the systems, and seeing that that was possible, that I could see all of the same wave dynamics operating in these oscillatory systems that I was working on at a material level, and seeing how parallel they were to the quantum mechanical world, it really allowed me to look at the system and be like, wait a second. I think that it'd be very easy, actually, to translate these oscillatory behaviors into a material vision of what's happening within the atoms themselves. So it's like, it's so funny that through biology, you can actually get into a kind of physics that starts to approximate something like what we're looking for.
And I think there are many branches of physics where things are still kind of causal. Like, I don't know, the physics of sand. There's all kinds of things where you can actually see the dynamics of the system actually evolving in time. And but you know, in this realm of, I don't know, quantum electrodynamics, quantum chromodynamics, string theory, aspects of cosmology, they start giving up on that and liking that we're kind of confronting the lack of sense in nature. And what I want to add in this regard is that I do wish that some section of physicists would say, you know what, even though I like the mathematics and the theory, let me try to, as you guys were saying, let me try to understand what's actually happening. And if I have to change words or coin words or draw pictures, I'll do it. And hopefully I'll find other people that want to talk about this without getting annoyed that I'm some sort of a heretic, because it's a normal thing that has been done countless times. We were people working on molecular physics, on atomic physics, on, you know, whatever it is. How do neutrinos interact with matter? You need models, and it shouldn't be that painful to deal with things that are not just math. But yet, one can see the it's like I don't know, like I wanted to say instantaneously spiritual corruption, but that's the wrong phrase. It's a cultural distortion when physicists become comfortable with words like the flavor of the quark. These things are quarks. They make up things. For example, some quarks make up things that are smaller than them. This quark is more massive, but it makes up some proton, and it has a flavor, or the electron has a spin, but it's not a spin. But I feel good using words that do not mean what they mean. That way I can confuse people and feel smart. All of that is so silly and primitive that it's begging for someone not just call things what they are, but also give the credit to the people who actually did the things. So you got to tell the history of physics right, and then you've got to actually call things what they are. But somehow, because of the physics pedagogy, that's just not attractive, and it's not done. About the budgets and the particle theory, I wanted to say that the danger of the idea that individuals cannot contribute. Part of the idea is that then it entails, because the problem someone has articulated, the solution would be very expensive and would require a very big group. In other words, we need $10 billion and a team of 2,000 physicists to address that. This is the kind of thing that was going on already when people were doing the superconducting super collider. To them, one of the justifications they used was, well, we need to find the top quark, and the top quark is the next level in physics. And I was at NYU at the time, and I was working with some physicists on some cosmic gamma ray detector, and a couple of them, I think it was Peter Nemeth and Alan Mincer, when they were in these teams of physicists who, outside of the superconducting super collider thing, were just trying to find the top quark. And guess what? They found it. Superconducting super collider was not really necessary to find the top quark. It wasn't. It was a fiction. And physicists, like any other constituency, wants money and they want support. That's lovely. The government should support big science, but at the same time, they create the distortion, which is we cannot make progress unless you give us 10 million and we get 1,000 postdocs involved. That is ridiculous. It's just really sad because such great breakthroughs have to do is just you look at someone like Faraday or someone like Einstein or someone like Heaviside. There's just so many examples of people just looking at something and coming up with a different way to talk about it. And then other people saying, yeah, that's great. You remember when Richard Feynman formulated Feynman diagrams, he presented it to a group of physicists. Niels Bohr was there. So of course, what did Bohr do? He stood up and he says, you know what? The principles of quantum mechanics already taught us that you cannot do that. You cannot draw the trajectory of a particle as a straight line. There is no trajectory. There has been no measurement. So what you've done is just wrong. Yet Feynman diagrams still exist. All it took was some kid from New York saying, you know what? Niels Bohr says, I cannot do these chicken wire lines. I'm going to do them anyway. Notice how easy. It's just so stunningly reasonable. Well, I think it's just, and then people copy it and then it propagates. And then the reason nobody sees the contradiction, which is Bohr is wrong, is because it's just not taught. People just, if you just don't teach it and teach the illusion that all these physicists agree and that they're always doing it right and that we should all shut our mouth because the only way is the way that's in the textbook, it's totally fiction. To me, one of the neat things that I found over the years, if you actually read textbooks and start comparing sentence by sentence, you find that they say different things.
What do you mean?
Well, physicists would want to assume that the textbook they teach is the correct textbook, and all textbooks say the same thing, but that's not the same. That's not the case. For example, Space-Time Physics, a textbook by Taylor and Wheeler about Einstein's special theory of relativity, refers very clearly to the round-trip speed of light. Other textbooks don't. In other words, one textbook will tell you the constancy of the speed of light is an experimental fact. And another textbook, for example, that one by Taylor and Wheeler, would tell you, no, it isn't. What's a fact is the average round-trip speed of light. When we measure the speed of light, we don't really measure it from here to here. What we do is we send a beam and we bounce it back. That's a round-trip speed, and then we take an average. And so that's one level of honesty. Another level of honesty is when we compare our average speeds over decades, we find that they change. Anyone who's an experimental physicist would admit that to you. You know, there have been different measurements of the speed of light. And then some of those, you know, I knew Ken Wilson was a Nobel laureate, and he thought maybe the speed of light is not a constant. Maybe it's changing throughout the age of the universe. So these are normal thoughts that normal humans have, but this is just not something that is welcome in a physics classroom, because above all, they need to convey the illusion that some things are set and they're very simple, one of them being the constancy of the speed of light. Einstein himself had to abandon the constancy of the speed of light when he formulates general relativity. In general relativity, the speed of light does change. But yet again, it's a weird pedagogical pattern whereby the craving for orthodoxy, for certainty, and for a closed system prevents genuine questions from being raised just because the teacher is uncomfortable with them. Heinrich Hertz once wrote in his book on principles of mechanics, this is in the 1890s, shortly before he died, maybe 1894, he says physicists seem uncomfortable when they're teaching the foundations of mechanics. They teach it like they want to get rid of it so they can get to the other stuff. And Hertz felt bad about that. So he felt, you know, I too feel uncomfortable. Like there's something shady there. And it's that discomfort that is precious, because that's what leads to things like Einstein's special theory. If people don't have that discomfort, then again, they think it's all architectural. Bricks were laid by
I wanted to ask you about people like Einstein and the revolutionaries that do change people's ways of thinking. What is it that you think unites them in their ability to actually be heretics? Like, why are some people, like, why in some case do you have somebody be like Heavisides being relegated to the dustbin of history, and you have in other cases people who become heroes and deities of science? Like, what is it that separates those people? Are they just better social networkers? Do they have more famous friends? or is there something about their personality? Like, what is it that makes somebody with heretical ideas have their ideas seriously entertained?
It's a great question.
Yeah, thank you. That's a great question. I'll give you 2 or 3 examples. Generally, I think it has to do with being part of the network. In other words, Maxwell is at the top of the network in Great Britain. Heaviside is not. Heaviside is an outsider. He lives in the periphery. He's a weirdo. He's a loner. He's publishing these electricity magazines. A guy like J.J. Thomson is at the top of the network. So then what do physicists say? Oh, in 1897, J.J. Thomson discovered the electron. It's not true. Other people had already published. I have a whole chapter about it, and numerous people have written about this. In other words, other people say since the 1880s had, for example, William Crookes, cathode rays consist of invisible particles that carry electric charge, and the electrical charge is negative. So, multiple people had talked about electrons in one way or another. J.J. Thomson is just another guy who's measuring the charge to mass ratio, which incidentally had been measured before him and after him and better than him. So he's not even the guy who gives the best measurements. But yet, because he's at this prestigious position, then he gets the credit. And similarly, so sometimes it has to do with connectedness. Sometimes it has to do with fame. There was this thing called the Matthew effect, which is basically from the Gospel of Matthew, meaning that sociologist Robert K. Merton, taking from the work of, I think it's Harriet Zuckerman, who had interviewed Nobel Prize laureates. She interviewed them and she found that again and again, they complain that they're getting more credit than they deserve. The question is why? And the answer is because they're already famous. So once you find out that someone's famous like Einstein, then you say, oh, and he also invented lasers. No, he didn't. But people want to, let's just give everything to Einstein. So there is this thing that happens, which is once you have this kind of figure. But and now I'll give 2 more examples. One of them is the case of Galileo. So Galileo is a prominent guy because he is a guy who loves to grandstand. Here I am, Galileo, and he's prominent because one of his friends is the Pope. I mean, Pope Urban VIII is a friend of his. Before Pope gets annoyed at him, Galileo had several audiences at the Vatican with his friend. So this is a high-ranking individual. And when Galileo has a chance to boldly defend Copernicus, what does Galileo say? He shuts his trap. In other words, the Inquisition has him. Well, first they say, Galileo, what you did is wrong. You have to come here and talk to us. He says, I can't go because I'm sick. They're like, you better come here. He says, I can't go because the plague. They say, you either come here or we're going to arrest you. So, okay, Galileo travels to Rome and goes to the Vatican. And then they tell him, you said that the earth moves and blah, blah. And Galileo says, no, I didn't. Imagine the degree of dishonesty. No, I didn't. They say, yeah, you did. You have a whole book and with the dialogue and here it is. And Galileo says, well, that's not what the book says. And then Galileo says, okay, if you lend me the book, I'll read it overnight and I'll tell you, what I think. And then Galileo says the next day, he says, I was reading my book and you're right. It seems to say that the earth does move, but I don't believe that. If you want, I could add 2 more chapters proving that the earth doesn't move. In other words, Galileo crosses the dishonesty line because he knows that if he doesn't cross it, they can kill him. So Galileo, in a long span of history, is rewarded, like Einstein, for keeping his mouth shut because he's seen as a great hero, while a guy like Giordano Bruno gets into the same problem. In other words, this is 1632 with Galileo. Already in 1592, Giordano Bruno was arrested. So we're saying 40 years earlier, Giordano Bruno is arrested. And one of the propositions that the theologians of the Inquisition, consultors, extract from Giordano Bruno's books as being false and censored is that the earth moves. In other words, there's 10 propositions, and one of them is the earth moves. And another one is the stars are worlds. In other words, what we believe, that they're solar systems and that other beings can live there, that there are mountains and valleys in those worlds and so on and so forth. So they extract these things and they confront Bruno. They say, well, you said these things. You know what Bruno says is, yes, I did. Well, you're wrong. You can't say that. That's a heresy. You can't say that the other worlds exist. Bruno says, yeah, I said that. I believe that. So he says it again and again, 8 years, and eventually they kill him. So you got the contrast between the guy who's willing to be bold and defend the truth and defend free thinking, and the guy who's connected and who's willing to shut his trap, Galileo. So then society takes Bruno's books and they burn them at St. Peter's Square. In other words, he wasn't just burned alive, they burned his books. And they made it illegal. It was illegal for someone like Galileo in Catholic lands to even write the name Giordano Bruno. For decades, it was illegal. You could go to jail. So they banned that book and remove him from this. They ban the guy. They remove him from discourse while Galileo becomes famous. So that's why when I started talking about Einstein, I say it very seriously that even though we remember Einstein for being kind of outspoken, what he's doing a big chunk of the time is shutting his mouth. So I think that society does latch on to some of these guys because of their connectedness and their ability to just roll with the flow. And if you do, then things are going to work out. You'll get the endowed chairs and the invitations, and people will not say you're a jerk. And that's a big deal.
That kind of casts it into a morally questionable light, doesn't it?
Yeah, it's too bad. So in other words, I think that what I want to teach and what we should be trying to teach each other is that we shouldn't do that. In other words, what we should see is that someone like Galileo was crushed. He was arrested anyway and house imprisonment. So this guy lost some of his liberties. And Einstein was somewhat crushed. In other words, over the years, he spoke less and less and was very cagey about what to say. So ideally, we don't want that. We wish that especially physics students would have the comfort to just say what they want and have that be part of the physics class. In other words, we're losing clever people to the humanities. And someone says, okay, when I became a social scientist, why? Well, I just couldn't stand the physics classes. I thought,
well, they're gonna eviscerate the humanities, and so we won't be losing people to the humanities because there won't be humanities departments anymore within the next 15 or 20 years.
Yeah. So then that's right. So then society puts these thoughtful people, many of these thoughtful people in the humanities, and they say, humanities is worthless. Let's eviscerate. Let's get rid of that crap. But they do also crush some of the sciences. Like, if you go to the physics building in my university, it's nowhere near as fancy as the engineering building or the medical buildings. So even to the humanities kind of looks up to the scientists, but the scientists say, hey, we're kind of abandoned and starving here. The university doesn't care about science anymore. This is a big disaster. So everyone's getting a little bit crushed by administrators.
Yeah, I always found it pretty funny how our friend Luca, who was in the physics department when we were at school, they were all busy crowded into this one office room together on the top floor.
No air conditioning in New York City in the summer.
Some people are in rooms without windows, like faculty in a closet without a window, and that's their space. It's really sad. It's just really weird. I don't know. Anyway, what are you guys working on these days? When you say you've got your book, tell me a little bit about that.
We've been working on a material interpretation of the mathematics of quantum physics. I mean, Shiloh is definitely the driver in terms of the analogies. I'm more of the historical driver.
Yeah, it's kind of a book in two parts. One is establishing why people stopped caring about mediators, and since they only really cared for a few minutes, it's an interesting story to try to unfold. And so Nastia is working on that part of it, which is sort of the first half. The second half is just, in some sense, providing one possible material interpretation of what could be happening. So finding a material explanation that's congruent with all of the maths of quantum mechanics. That we're not saying it is so, but from the standpoint of a traditional hypothesis, we're saying this could, in fact, explain what we're seeing here. And we don't know if it's true. Maybe somebody has a better idea, but here's an example of how this could be done. And so that's something we've been working on for almost a decade now, that model of the atom. And we essentially boil everything down to giving the atom, interpreting a lot of the wave mechanics and the wave deconvolutions of the wave mechanics of the electron to give the atom a shape, to give it architecture that's capable of doing all of its magical tricks. And so, yeah, it's been a wild project, and writing the book is just somebody, an anonymous donor, actually a professor at a really well-known school, gave us money to write this book and take the time to do it finally. It was funny because we were just chatting and he was like, we shared with him some of the thoughts that we'd had about the atom recently, and he said, "My God, have you published this stuff?" And we said, "Man, are you?" We both kind of looked at each other for a second, and then started laughing, like, "Of course not. You can't publish this stuff." And so he said, "Well, you need to write it in a book," and that's what we've been working on, putting it into text this past year, and we're getting close to having a draft of it. It's really exciting. But again, we're in that same trap where it's like, like you said at the beginning of this talk, you can write an incredible idea down, but getting people to read it requires you having that Oprah, right? For us, that would be like the Joe Rogan podcast or something. Like, you need somebody to step up and be like, "Hey, this is a good idea. Look at it." And so God knows, like, when, if we'll have that sort of fortune or not.
And it's something that I think about all the time, where there's clearly a desire to be mystified.
Yeah.
People love to look in the world and to be bowled over by how mysterious and inexplicable it is. Like, I don't know, have you ever looked into non-duality as a spiritual practice?
I'm not sure what you mean, non-duality. Maybe not. What is it?
So non-duality, in the best way that I can explain it, is that there is...
Well, it's a philosophical approach to the world.
Yes, and the philosophical approach to the world basically says that there is nothing there, and everything is an illusion, and so you have to be able to do this magic eye thing where you see the world as not really being there, and live as if you're just participating in this momentary dance, and everything will dissipate. And we've talked to a couple of people that are really big non-dualists, and it's just really struck me that the reason that it's appealing to people is because it gives you this titillating sense of always being on the verge of understanding something, but it also gives you the permission to not really worry too much about understanding it, and so you can let it wash over you like waves of thoughts, or the resonance of the universe, and you can just bathe in it and be satisfied to know that you are this minuscule corpuscle that's dancing on the firmament. And so we're always preoccupied when we're writing this book of, what does it give people? Like, how many people are truly preoccupied with the question of understanding? Like, how many true scientists are there in the world that want to do away with the mysticism and want to do away with the confusion?
In some sense, the success of a book has a lot to do with what it gives the reader, right? The most popular books are often self-help books. They give someone something immediately actionable. It's like, oh, this is how you can change your life and it will be better tomorrow. And that's kind of those are the most tasty, popular ideas in the world. And so we're like really always struggling when we're writing this thing about, what are we offering the reader? What are we really giving them? Because in some sense, it's a spiritual thing. It's an empowerment. It's like, you can understand the quantum atomic world. It's not this inconceivable, like, hellscape of chaos. There's actually sense to be made, and that's good for you. That's spiritually good for you to understand how the world works. But that's a hard thing to sell at the same time.
I just always think about the fact that people turn away from it. That Descartes comes up with the mechanistic philosophy, and within 100 years, people are like, no, we don't really mean mechanism. Like, we mean the mathematical study of forces.
Yeah. So I want to get a quotation that I think you would like, because it's something by Bertrand Russell, which has to do with this. It also reminds me of other things, like when Carl Sagan used this phrase, "the demon-haunted world." Like, if you like that. So they like the renunciation of understanding, because somehow it's fulfilling that they don't have to keep going and going. And at some point, they got to the core mystery, which is the mystery that will never go away. And Heisenberg called it the end of the road. He really thought that when he had done this uncertainty principle, that they were at the end of the road in physics. And Karl Popper, for example, talks about that. I met with a guy, or back then he thought it was at the end of the road. And after that, they start finding all these other particles. How could you be at the end of the road when leptons and cascade particles and neutrinos, all kinds of stuff hadn't been discovered yet? And yet these people think that they're done. It's because at some point, it's almost like giving people the illusion that they have reached the final revelation. that the black wall. At the end of the inquiry, where you find light and light and light, eventually you find a big black wall and you have to accept it and gaze at it because somehow it feeds you. But give me a second. Should I go get the quotation?
Yeah, that would be
Okay.
fantastic.
So get me back a little bit on track when Nastasia was saying something about, what was it called? The non-dualism? Is that what it is?
Mm-hmm.
Non-dualism. So basically, the non-dualists are people who think maybe that it's not just matter and spirit, but that the world instead is an illusion. Is that what you were basically saying? That it's this ephemeral illusion that at some point will culminate in the vanishing of one's existence. Something.
It's kind of like, it's a little bit like James's radical empiricism. It's like the only thing that we really know is our experience, and so therefore experience is the foundation upon which reality is built, not material reality. So,
but then again, is that's not a perspective you're adopting? It's just something you're reacting to, or do you sympathize with it?
It's something that I really like to try to understand. My thing is always trying to figure out how to get into somebody's head so I can understand the way that they're thinking, for quantum physics or for non-duality or for anything else.
I mean, my approach is more just like, well, even if that is so, it certainly appears that physical reality behaves a certain way, and therefore it's worth understanding in its own right. And so it's kind of a non sequitur as far as I'm concerned. It's like, I guess everything's technically all happening in my head, but it's happening in her head and your head, and we can all kind of agree that it looks like this, so maybe we should concern ourselves with that.
Or there's some kind of humility if one says, maybe everything in the universe is simply a daydream that I'm having, or maybe I mean, that one is not humility. That one involves a guess that one is the main center of existence or reality. But the humility is in saying, maybe the things that I see, that there are humans and they die, does show that I'm human too, and I too will die, and the world will go on without me. Therefore, let me try to figure it out so I can give something to other people that will move things forward, or that will leave the campsite better than when I found it. That kind of thing. But the quotation that came to my mind, just because of there's this kind of like back and forth between the desire for clear-cut, somewhat mechanistic explanations, which used to be kind of science at a classical time, or at least in the early Renaissance, or saying not the early Renaissance, but at least the Renaissance at the time of Descartes, this idea that we can, through our reasoning powers, get to know this mysterious stuff that we call the world. And on the other side of the tension, there are these groups that say, no, you can't. No, you can't, because your rational thinking is an illusion, and it is fundamentally at odds with reality. And reality is illogical, acausal, non-represent. It cannot be represented. It cannot be quantified. So there's that conflict, and it reminded me of this quotation by Bertrand Russell. So as you know, of course, this guy is not a religious person, and he had this rather I don't know how to say it. It's almost like what we would sometimes call the objectivity. He had the desire for objectivity. So in 1957, he writes an essay titled "How to Read and Understand History," and he talks about how philosophy had a brilliant beginning, he claims, in ancient Greece. But then he says that from that day, that's probably my email, so let me just see if I can turn that off. I'm kind of surprised that okay, there, I turned that off. All right, so we got this guy, Bertrand Russell, who's kind of someone who aspires to some kind of objectivity. And he claims that philosophy had a bright beginning, but that it dimmed. He says, from that day to this, there has always been thought to be something divine about muddle-headedness, provided that it had the quality of spiritual intoxication. A wholly sober view of the world has been thought to show a limited and pedestrian mind. From Pythagoras, this outlook descended to Plato, from Plato to Christian theologians, and from them in a new form to Rousseau and the Romantics, and the myriad of purveyors of nonsense who flourish wherever men and women are tired of the truth. So it's like he realizes that there's something in, I don't know, I would kind of put it in mechanistic terms, mechanistic philosophy of, yeah, I just want to understand how things work. I just want to have a picture. That kind of account, when that kind of account competes against a more spiritual or religious or mysterious, ununderstandable account, the former account just fails because it's people are not that interested in the dynamics of things. They're more interested in the mystery and the confusion. And it takes me back to Einstein too, because Einstein thinks one of the possible explanations for why people like him so much is because they don't understand his theory. And I think Anastasia came close to, she said something like this a while ago, which is that the mystery is fascinating or attractive, that it lures people in. While if there were no mystery and Einstein were just talking about some, I don't know, the chemical composition of some complex molecule, people are like, whatever, I'm not that interested. But it's something like, dude, the curvature of space-time, that kind of blows my mind. Then that's something they can really get into, because that feels meaty. Or anything else that sounds where we expected to find something dry and mechanistic there, but instead we find something weird and perplexing, and people are like, yeah, I think I'm getting into physics now. But I'm more of the group in which I do want clear understanding, and I wish there were more of this, like you guys are doing. You're trying to make a model of the atom. I think that's great. I've literally said in my class, you will not find a physicist in the physics department who is trying to make a model of the atom. I've said that just because that just shows how the culture.
I am technically in the physics department. So.
But I'm saying at my university,
that
go there and try to find someone who will tell you that maybe Einstein's theory of gravity is wrong, or that they're trying to come up with a new model of the atom, and that's just not generally the way they think, because the paradigm gives them a framework for what are the legitimate questions and what are the stuff that are beyond the pale.
I mean, and just to be clear, we don't think any of these, we don't accuse anybody of being wrong necessarily. We just don't think that their interpretations are rational. They're not actually coming up with material explanations for the phenomena. It's like the interpretive step that we're really taking aim at in this work.
The mechanistic view of the world. I'm really glad that we found you. One of our listeners recommended that we contact you, and I looked through your work, but I had no idea of just how deeply resonant I would feel with the way that you see the world. And I just
that's partly because what I've been talking about here is not stuff that I normally write about. In other words, what originally got me into history of physics were these puzzles in relativity and quantum mechanics, and I just never got around to writing about it. So for example, I do think the Copenhagen interpretation is just wrong. I do think the atom has a structure, and there are no good models of it yet. And so I have definite opinions about these things, but it's somehow life takes a detour, and one ends up writing book after book about
other. That's kind of like that's the real punchline at the end of our book, is that all of these paradoxes that are just accepted about light in particular and electromagnetism, we say at the end, we're going to deal with every single one of those. They don't have to be paradoxes. Wherever you see a paradox, it means that there's something missing in our fundamental conception of what these equations are telling us about the material reality. So I feel like those paradoxes are the really meaty places that need to be examined, because that's where we can learn the most about what's actually happening down at that scale.
So, Michael, what do the physicists and astronomers at the university say when if you dare to venture some of your concepts?
I mean, I walk the line. Yeah, I walk. We'll see after this book comes out. Yeah. But I walk the line really tightly. I mean, I try really hard to always present the mainstream perspective first. And then
with empathy and support.
Exactly. I've really tried to cultivate that.
To say it's basically right.
It is. Yeah. I'm not saying anything's wrong. I'm just saying it's not the finished story, really. It's like there's things here that don't make sense. Actually, the reason that I love teaching astronomy and planetary sciences is because in some sense, they're able to fluidly move in a way that some of these other sciences are not able to. We're discovering so much with our new telescopes about other solar systems that are really they're inevitably rewriting the way that we see our own solar system, and it doesn't really change anything on Earth for people, right? It's like those little, okay, so we think the solar system formed a little bit differently now, all of a sudden. It's somehow less dangerous, and so I don't know. I'm also lucky because it's a tiny department. It's not a big research institution. I don't have anybody breathing down my neck. And so I don't know if I'm allowed to, but I do explore the edges of these things a little bit in a way that I probably couldn't at a more research heavy institution. So we'll see what happens, man. I don't know. I'm not I'm not trying to build a career necessarily in academia, but
We've had a lot of success talking to emeritus professors. Like we've recorded probably 250 conversations. We've released 200 of them. And most young physicists, you start to kind of poke and prod at them in conversation where you're like, yeah, well, isn't it possible that this is just one interpretation? And they tend to shut down. But you talk to an emeritus professor and they'll just kind of sit back and be like, yeah. No one's like, we had John Moffat from the Perimeter Institute, who, I mean, he had some like really heretical ideas about the variable speed of light at the Big Bang and I think that his career was characterized by having some out there ideas, but he was still very much pro Big Bang. And I remember we were talking about redshift. And I was like, well, isn't it possible that there are other explanations for redshift about something to do with the nature of light that we don't understand yet and some material interaction? He's like, yeah, nobody's studying it, but yeah, possible. And so I think you talked about this huge arc that somebody follows across a career where you spend 15, 20 years just learning to be quiet, waiting for the moment when you can have your own ideas. And I think that emeritus professors have gotten to the backside of that and they're like, I have ideas, and if you want to talk about crazy stuff in physics, I am happy to do that. And it's been really good for us. I'm trying hard to get John Clauser, who got the Nobel for the Bell's paradox stuff. His phone number is just on the internet. And so I actually called him the other day and I talked to him on the phone for a long time. And he's like, maybe gonna come by. But I feel like when somebody's won a Nobel Prize for something, there's almost no chance that they're gonna be amenable.
And they might have an advisor that tells them what is good and what is not good. And well, now that you're a Nobel Prize winner, you can't just meet with anyone. You have to vet it with me.
Oh, interesting.
It could be some of that. But
Maybe.
yeah, I'm glad to know that you're finding more open-mindedness in emeritus professors. Certainly they were around before much of the orthodoxy in modern physics had set in place, and they've been around so long that they've seen things come and go, and things that were hot become cold. String theory, it's just around the corner, string theory. And people start realizing maybe there's nothing here. And thousands of people have wasted millions of hours on this nonsense. And instead of actually looking at an experiment to try and explain one real thing. And so it could, yeah, so that's glad but it's also sad. It also shows that partly many emeritus physics and many fields at universities, what they feel is that they've kind of been neglected a bit and that they wish they were consulted more. But if it comes especially from ideas that they had and that they never fully baked and that they're kind of welcoming a chance to finally talk about, that would be a great way to help open a conversation. In other words, bringing in people who have a hell of a lot of expertise and sure know what they're talking about, but also are willing to go out a bit on a limb and just think aloud and get other people talking too, rather than, outsiders being shut down because they haven't won a Nobel Prize yet and therefore their opinion is unwelcome.
Yeah, I mean, we're organizing our first conference. It's actually going to be in Austin next year, April 7th and 8th for the eclipse, where we're bringing together, all the people that we have come across that are in the mindset of seeing science this way, not just physics, but just science in general, of let us stop and consider that there are other myths that we can tell ourselves about the way that the world works.
And sort of ironically, all of these people had illustrious careers at the academy, but then left in order to do the kind of work that they weren't able to pursue under those confines.
Oh, they did. So they weren't just retired. They retired partly in order. You mean the people who want to go to the conference?
Oh, just the speakers that we have lined up so far. Just the people that we've really resonated with seem to oftentimes have had a lot of success, say, in engineering or some very acceptable discipline at the academy, but they spent a lot of their time thinking while they were there that, hey, these things that I'm studying in my little engineering context, they actually could explain a lot of the problems I'm seeing in these other disciplines. And as soon as they open their mouths about that, they're basically driven out of their position. It's a very, very it's almost a boringly predictable outcome. And so, it's going to be a really good crew of people. It would be freaking awesome if you could come by and give a little talk, depending on your availability, because I feel like you sew together the social landscape of how this works in a really beautiful way. It's been a real privilege to meet you today.
I'm happy to meet both of you, and I would be happy to visit with your conference. The only variable is that you are doing it. I don't know if it's on the date of or around the eclipse. So I haven't decided yet where exactly in Texas will I be to see the eclipse. But I do want to see it from some good place. And apparently Austin is not quite right, the best for it. Were you guys actually thinking of having a conference on the day of the eclipse, or
it's going to be 2 days? Yeah. So the day before, we'll also be having it, and we're going to have it on the eclipse. But I think the sun is...
It is on the path of totality.
There's probably some smaller towns that would be a little bit darker, but it is still right. It's right there on the border. So we'll all go out and view it on the Monday, but we'll also have talks on Sunday.
Because I keep hearing people say that Austin is on the verge, and then I go and I look at the NASA website, and NASA's like, it's on the southern limit of the path, but there's still 1.5 minutes of totality. And I'm like, how much more totality do you need?
People are so greedy. Once totality is so close, people are like, I really want as total totality as I can. So they're like, I'll drive for 3 hours to get that.
Still 1.5 minutes. I mean, totality is totality, and so you will get totality in Austin. So.
Yeah, they just want a few more seconds of it.
Yeah.
But I will be happy to, we can keep talking about this, but I'd be happy to participate with you in this conference in one way or another.
That'd be amazing.
So I look forward to it. And especially that you guys are coming to Austin is great to know, because it'd be cool to talk in person.
Yeah. Even if you can't make it to the conference, maybe we can get a cup of coffee or something. It'd be great to just meet you.
And there's a lot more topics. We just,
I know.
We've beaten this horse dead. There are
so many books. You've written so many fascinating books about Pythagoras. You wrote one about Trump. You wrote one about negative numbers. It's just you've been thinking so widely on these topics that it's obvious that we've just started to scratch what's there.
Yeah, so one thing I can anticipate about, if you look at my stuff more closely, that one thing you might like is my books on the history of math have some particular chapters you would like to look at, because this back of the mind assumption, which is physics depends in math and the math is correct. There are, this guy I was mentioning, Oliver Heaviside, he basically invented vector algebra. And to do that, he had to change certain things in math, basically in the mathematics of quaternions. So people come along, whether it's William Rowan Hamilton or Oliver Heaviside, and they say, you know what, if the commutative rule of multiplication just isn't true? Can I make an algebra where commutative rule just doesn't hold? And the answer, of course, is yes, you can. Can I make an algebra in which the associative law of multiplication doesn't work? And their answer is yes, you can. And they did. So it's interesting to see, if one actually looks at the history of math from the perspective of physicists and astronomers who specifically, let me tinker with the math and change it a bit so that it fits the physics better. Then one starts to get a sense that there's an unexplored plasticity in pushing back on some of the equations that are given to us as if, no, the equation is rock solid. You have to accept it. There's no more way. This is just the structure of reality. It isn't. There are many ways in which the math sometimes has a mismatch with reality, and sometimes it's scientists or physicists who have said, okay, well, let me come up with a slightly different math, and next thing you know, it's being taught at college. So I deal with that when I'm looking at the history of negative numbers and imaginary numbers and vectors, and I think it's an important thing that should be taught to physicists, because otherwise they think the math is this rock solid structure that cannot be modified. So I think that sociology is very flexible, physics is a little bit flexible, but math is rock solid. It isn't. Again, there are things there that have changed and continue. As you well know, non-Euclidean geometry. How many hundreds and thousands of years that people think the angles of a triangle must be equal to two right angles, i.e., 180 degrees? And then people say, maybe not. Let's make an algebra in which they don't. I mean, a geometry in which they don't. Will geometry fall apart? No. Is that geometry useless and ununderstandable? No, it is useful for describing the path of light in actual space. So again, it's so fascinating that this is part of what I like to call physical mathematics, but instead people continue to view math as this independent, intractable thing that only imposes conditions on what physics can do, rather than on something that should also be shaped by the experimental discoveries, not just theoretical physics. So anyway, that's something to consider as you're doing your work on quantum interpretation, because of course otherwise the standard thing is thou shalt preserve the Schrodinger wave equation, and the uncertainty principle is a fundamental law of reality. These are just Einstein saw them as stopgaps. Like this works, but it's gonna be something better, and he was groping for it and until he died.
I think that this is a really good illustration of how important it is to have a scene where you were saying earlier in the conversation that there's no such thing as an idea that is formed by a group, right? There's not a collective emergence of some idea that no one can take credit for. There's definitely somebody's brain in which the idea foments.
Sometimes there's 2 or 3, but it's not 1,000.
But it's a scene. It's a scene of people that can all bounce these ideas off of each other. And I feel like our scene has gotten a little bit bigger now that we have met you. And I'm really, really grateful for that.
Great. I'll take the compliment, and maybe we can leave it at that. Thank you so much, guys. Thank you both for having me. And I think you're doing great work, both in the podcast and your ability to actually be free thinkers in the realm of physics and astronomy. And I know you're also in biology, Anastasia, right? So keep it up. As I said, it's one to rattle off example after example were people who were not at, say, an endowed chair of physics, nonetheless made interesting, important contributions that are taught, but just are not taught with the biographical background to empower students, to actually let them know that, they can do it too. It's, sometimes it was old people, sometimes it was young people, and so on and so forth. It's not, I don't know, the world is not as finished as some science educators want to tell us. It's all nearly done. The only way to contribute is to learn the most sophisticated mathematics, which are hopelessly out of your reach. So don't even try, and please go to home economics. It's a very weird view on life.
Yeah, definitely.
Well, we've managed to not get ourselves fired this far, so we'll see what happens.
Thank you so much, Alberto.
All right, sir. Thank you so much, and we'll be in touch.
Take good care. I'll be happy to hear back from you. Take care. Thank you.
Have a great rest of your night. Bye.
Bye, everybody.